Mastery practice questions 1. A. Given the angle ABC is equal to 50 degree, the angle BAC is 72 degree, and the length of C is equal to 5.8 centimeter. Calculate the length of A and B. For the angle ABC equal to 50 degree, the angle is at the point B. So let's say this point here is the point B, so the angle here will be 50 degree. And for the informations, angle at BAC equal to 72. The angle is at the point A. So let's say this is the point A. Then the angle here will be 72. Then the point here will be the point C. For the small letter C, the length is equal to 5.8. This will be the length which is opposite this angle capital. So the length AC is opposite to this angle 50, which is the angle B. So the length AB will be the small letter B. And for the length BC is opposite this 72 degree. So the length BC will equal to the length of the small letter A. So first we're going to find the angle C. So the angle C will be 180 minus 50 minus 72, which is equal to 58. Here the length of A is opposite this 72 degree, whereas we have the informations of the length of C, which is opposite this 58 degree. So using the sines rule, we can find the length of A. So A over sine 72 degree, this is equal to 5.8 over sines 58. So A is equal to 5.8 over sines 58 times sine 72 degree, which is equal to 6.504. Next, the length of B is opposite this 50 degree, and using the informations of the C and the angle 58, we can find the B using the sines rule. So here B over sine 50, this is equal to 5.8 over sine 58. So B will equal to 5.8 over sine 58 times sine 50, which is equal to 5.239. Questions B. Given the sides of triangle PQR are P equal to 8.28 cm, Q is equal to 6.56 cm, and R is equal to 3.63 cm, find angle P, angle Q, and angle R. So let's say the triangle PQR look like this. So the longest sides here will be the P, which is equal to 8.28 cm. And this will be the shorter side, we're going to be the R, which is equal to 3.63 centimeter. Then the length here will be the Q, which is equal to 6.56 centimeter. So here the length of the small letter P is opposite to this angle here. So this will be our vertex of the capital letter P. And this will be the angle P. The length of the small letter Q is opposite to this angle. So this vertex will be the capital Q, and this will be the angle Q. Then the vertex here will be the R, and this will be the angle R. So here in the triangle PQR, the length of three sides are given. Then we can find the angle using the cosine rule. So first we're going to find the angle P. So it will be 8.28 square equal to 3.63 square plus 6.56 square minus 2 times 3.63 times 6.56 times cos angle P. Cos angle P will be 3.63 square plus 6.56 square minus 8.28 square. Then divide by 2 times 3.63 times 6.56. So the angle P will be the inverse cos here, which is equal to 105.03. So next, the angle Q is opposite to the length, 6.56. So using cosine rule, this will be 6.56 square equal to 3.63 square plus 8.28 square minus 2 times 3.63 times 8.28 times cos angle Q. So cos angle Q will be 3.63 square plus 8.28 square minus 6.56 square and divide by 2 times 3.63 times 8.28. So the angle Q will be the inverse cos of this answer, which is equal to 49.92. So now, as we already find the angle P and Q, to find what will be the angle R, we can use 180 degree minus 49.92 minus 105.03. This is equal to 25.05. Questions number 2. Finds the value of x in each of the following diagram. Questions A. So first we can find what is the angle XYZ. It's going to be 180 minus 55 degree 13 minutes, which is equal to 124 degree 47 minutes. So now we can find what is the angle X here. It will be 180 degree minus 124 degree 47 minutes minus 31 degree 52 minutes, which is equal to 23 degree 21 minutes. So here you can find the x using the cosine rule or using the sine rule. So here I just going to solve this using the sine rule. So here the x is opposite to the angle x here, whereas this 9 cm is opposite to the angle 31 degree 52 minutes. So x over sine 23 degree 21 minutes, this is equal to 9 over sine 31 degree 52 minutes. So x will equal to 9 over sine 31 degree 52 minutes times sine 23 degree 21 minutes, which is equal to 6.757. Questions B. The PQRS is a cyclic quadrilateral which has the characteristic of when you sum up the opposite angle, it is equal to 180 degree. So using that characteristic, we can find the angle QPS. So it's going to be 180 minus 77, which is equal to 103. So now we're going to refer to the triangle PQS. So the x here is opposite to the 103 degree. So we have two sides and one included angle here. So using the cosine rule, we can find for the x. So x square is equal to 3 square plus 6 square minus 2 times 3 times 6 cos 103. So the x will be the square root of this answer, which is equal to 7.287. Questions number 3. The diagram on the right shows a right angle triangle ABC. Point D lines on AB. Calculate A, the length of AC. So first we're going to find the length of BC. So refer to the right angle triangle DBC. We can find the length BC using the Pythagoras theorems. So BC will equal to the square root of 10 square minus 3 square, which is equal to 9.539. So AC, which is the hypotenuse in the right angle triangle ABC, can be found also using the Pythagoras theorem. So it will be the length of AB, which is 10 square, plus with 9.539 square, which is equal to 13.2. Questions B. Calculate the area of the triangle ADC. So in the triangle ADC, the length of three sides has been given. So you can calculate the area of ADC using the Heron's formula. Or you can also find the triangle ADC, the area, using the area of the triangle ABC minus the area of the triangle DBC. So here the triangle ABC and the triangle DBC is a right angle triangle. So we can find the area using the formula 1/2 times base times height. So the area of the triangle ABC will be 1/2 times the base, which is the 9.539. The height will be 10. Minus the area of DBC will be 1/2 times base 9.539. The height here will be 3. So the answer is equal to 33.387. Questions number 4. Given triangle XYZ such that angle X equal to 42.2, X equal to 10 cm and Z equal to 13.4. A. Sketch two possible shapes of the triangle. So the questions A here involve the ambiguous case. So let's say the angle 42.2 degree is here, then this vertex will be the X. Then I'm going to label this length using the longer sides given in the questions. That will be the Z. Then the length here will be the X equal to 10 cm, and is the length which is opposite the vertex X here. So here the length Z is opposite this vertex, then this will be the vertex of the capital Z. Then this will be the vertex Y. Now to sketch two possible shapes of the triangle XYZ, we are going to swing the shorter side, which is the YZ, toward the left hand side. So here this will be the positions of another point Z. So this will be the first possible shape of the triangle XYZ. And this will be the second possible shape. Questions B. Hence, finds the possible values of Z. So in the shape 1, the angle Z will be an acute angle, whereas in the shape 2, the angle Z will be an obtuse angle. So first, let us look at the shape 1. This angle Z is opposite to the length 13.4, whereas this 42.2 degree is opposite to the length of 10. So using sines rule, we can find what is the angle Z. So 13.4 over sines angle Z, this is equal to 10 over sines 42.2. So sine angle Z will be 13.4 times sines 42.2 divided by 10. So the angle Z will be the inverse sines here, which is equal to 64.17. So based on the first diagram here, as the length of YZ here, they are the same. Therefore, this is an isosceles triangle. Then the angle Z here will be equal to 64.17 as well. Therefore, to find the obtuse angle in the possible shape 2, which is also here, then we can use 180 degree minus 64.17, which is equal to 115.83. Question C. Calculate the area of triangle XYZ for the obtuse angle of Z. So this is referred to the triangle of the shape number 2. So in shape number 2, we already know two sides. So I just need to find the included angle, which is the y. Then I can solve the area using the formula 1 over 2 AB sine C. So here the angle y will be 180 degree minus 42.2 minus 115.83, which is equal to 21.97. So area of the triangle XYZ here will be 1 over 2 times 13.4 times 10 times sine 21.97, which is equal to 25.066. Question number 5. The diagram on the right shows 5 points A, B, C, D, and E, which forms quadrilateral. BCD is a straight line, angle ACB is obtuse, and the area of triangle ADE is 20 cm square. Calculate A, the length of AD. So in the triangle ACD, the length AD is opposite to the angle ACD. And we already know the length of AC and CD. So we just need to find what's the angle ACD, then we can solve the length of AD using the cosine rule. So in the triangle ABC, this 30 degree is opposite to the length 5 cm here, and the length 9 cm is opposite to the obtuse angle of the ACB. So using sine rule, we will find the angle ACB. So here 9 over sine angle ACB, this is equal to 5 over sine 30 degree. So sine angle ACB will equal to 9 times sine 30 degree divided by 5. So the angle ACB will be the inverse sine here, which is equal to 64.16. But don't forget, the angle ACB is obtuse. To find the obtuse angle, it will be 180 degree minus 64.16, which is equal to 115.84. So now, the angle ACD in the triangle ACD will be 180 minus 115.84, which is equal to 64.16. So using cosine rule, we are going to find the length of AD. So here AD square is equal to 5 square plus 6 square minus 2 times 5 times 6 times cos 64.16. So AD will be the square root of this answer, which is equal to 5.903. Questions B. Calculate the angle DAE, which will be here. So based on the informations in the questions, we know that the area of the triangle ADE is equal to 20. In triangle ADE, we already have two sides, and the angle DAE will be the included angle. So using the formula 1 over 2 AB sine C, we can find the area of the triangle, which is equal to 20. So here it will be 1 over 2 times 10 times 5.903 times sine the angle DAE. This is equal to 20. So here I can simplify the number 10 here by dividing it with number 2, which I'm going to get 5. So sine angle DAE will be 20 divided by 5 times 5.903. The angle DAE will be the inverse sine of this answer, which is equal to 42.66. Question number 6. In the diagram on the right, PQR is an equilateral triangle with sides of 6 cm and lines on the horizontal plane. Point T is 4 cm vertically above the midpoints of PQ. Calculate A, the angles formed by TR and triangle PQR. So PQR is an equilateral triangle. This means the length of PQ is also equal to 6. And this point here will be the midpoint. Therefore, the length to the midpoint here, the P to the midpoint here will be 3 cm. This is also 3 cm. And the length from the midpoint to the point T will be 4 cm. So the angle formed by TR and the triangle PQR will be the angle here. So if we look at this triangle from the right hand side, then it will be look like this. So next I'm going to find the length from the midpoints to the arm. So the triangle that I have here is also a right angle triangle. So here we can find the length from the midpoints to the R using the Pythagoras theorems. So it will be the square root of 6 square minus 3 square, which is equal to 5.196. So for the angle that we want to find here, this 4 cm will be the opposite sides, whereas this 5.196 will be the adjacent sides. So using the trigonometric ratio of tangent, which is equal to opposite sides over adjacent, then we can find for the angle R. So tangent angle R will equal to 4 divided by 5.196. So the angle R will be the inverse tan of this answer, which is equal to 37.59. Questions B. Calculate the area of the plants TPR, which is in the shape of a triangle. For this triangle, as T is vertically above the midpoint, the angle here will be 90 degrees. T is the hypotenuse and can be solved using the Pythagoras theorem. So TP will be the square root of 4 square plus 3 square, which is equal to 5. This triangle is also a right angle triangle. So we already know the length of 4 and 5.196 from the questions in A. So we can find the length of TR, which is the hypotenuse. So TR is equal to the square root of 4 square plus 5.916 square, which is equal to 6.557. So now we already have the length of 3 sides of the plant's TPR. So here we can find the area using the Heron's formula, or the area equal to 1 over 2 AB sine C. So let's say I solve this using the formula 1 over 2 AB sine C, then I will need 2 sides and 1 included angle. Let's say the included angle that I'm going to choose here will be the angle at the P here. Then using cosine rule, then I can find the angle at the P, which is opposite to the length TR. So 6.557 square equal to 5 square plus 6 square minus 2 times 5 times 6 cos angle P. So cos angle P is equal to 5 square plus 6 square minus 6.557 square and divide by 2 times 5 times 6. So angle P will be the inverse cos of this answer, which is equal to 72.54. So area of plants TPR will be 1 over 2 times 5 times 6 times sine 72.54 degree. This is equal to 14.309. Question 7. A group of Girl Scouts took part in a camping. They set up 3 tents with the position as shown in the diagram on the right. The positions of the 3 tents form a triangle ABC. A. Calculate the obtuse angle ACB. So here will be the obtuse angle of the ACB. So based on the information in the diagram, this 50 degree is opposite to the length of CB, and this admeter is opposite to the obtuse angle ACB. So using sine rule, we will find the angle C. So it will be ad over sine angle ACB. This is equal to 7 over sine 50 degree. So sine angle ACB will be at times sine 50 degree divided by 7. So angle ACB will be the inverse sine here, which is equal to 61.10 degree. To find the obtuse angle ACB, it will be 180 degree minus 61.10. It will be equal to 118.90 degree. Questions B. Draw and label another triangle other than triangle ABC, which shows the possible positions of 10C such that the distance AB and AC and the angle ACB remain unchanged. So here the points that is going to move will be the point C. So these questions involve the ambiguous case. So here we're going to move the point C to the left hand side. But first I'm going to extend the straight line BC. So here will be the new positions of the C. Then after you connect the point A to the new point C, then you're going to have another triangle of the ABC, which look like this. So in this new shape of triangle ABC, the length of AB remain unchanged, and the length of AC remain unchanged, and the angle ABC is also remain unchanged. Question C. 10C has to be relocated to other positions, but the distance between 10A and 10B and the angle BAC formed between the 10s remain unchanged. Calculate the distance AC such that only one triangle can be formed. So here, the 10C will be the moving point. And as the angle here has to be remain unchanged, this means we can only move the point C horizontally to the right. So to meet the conditions such that only one triangle can be formed, we are going to move the point C such that we're going to create a right angle triangle ABC with the length AC as the base. So here will be the new positions of the 10C, and this is 90 degree. And this will be the length AC that we want to find. So here we can solve this using the trigonometric ratios, as this is a right angle triangle. So using the angle 50 here, the length BC will be the opposite sides, whereas this AC will be the adjacent sides, and this admeter will be the hypotenuse. So here it involves the adjacent sides and the hypotenuse. Then we're going to solve this using cos. So here, cos 50 degree, this is equal to the length of AC over ad. So AC is equal to cos 50 degree times ad, which is equal to 5.142. Questions number 8. The diagram on the right shows a glass block in the shape of a pyramid VABC. The base of the block is an isosceles triangle and AB equal to AC, which is equal to 5.2 cm. V is the vertex of the block such that BV equal to CV equal to 3 cm. The angle between the inclined planes BBC and the base ABC is 50 degree. Calculate A, angle BAC given the base area is 8.69 cm square. So based on the diagram, the angle BAC will be here. And the area of the triangle ABC will equal to 8.69. So as the angle BAC is the included angle here, so we can solve this using the formula 1 over 2 AB sine C. So here it will be 1 over 2 times 5.2 times 5.2 times sine the angle BAC. This is equal to 8.69. So here we can simplify this. So this will be 2.6. So sine angle BAC will be 8.69 divided by 2.6 times 5.2. So the angle BAC will be the inverse sine for the answer here. So the answer will be 39.997. So after we round it off, this is going to be exactly as the 40 degree. Questions B. The length of AV given the angle between the line AV and the base is 25 degree. So based on the questions B, the angle 25 will be here. And this will be the midpoint. Let's say we label this as point M. So based on another information, which is the angle between the inclined plane BBC and the base is 50 degree, the angle 50 degree will be here. So based on the duplicate diagram that I have here, if I remove the base, then here we got the triangle VAM. So here we can find what is the angle V by using 180 degree minus 25 minus 50, which is equal to 105 degree. So here the length AV is opposite to this 50 degree, and this 105 degree is opposite the length AM. So if we can find what is the length of AM, then we can solve this using the sine rule. So this is the diagram of the base ABC when you're looking from the top. So as M is the midpoint, then the angle created here will be a 90 degree. And from the questions A, we know that the angle BAC is equal to 40 degree. So when we split it into half, then the angle formed here will be just 20. So based on the right angle triangle ABM with the angle 20 here, the length AM that we want to find will be the adjacent side, whereas this 5.2 centimeter will be the hypotenuse. So here we can use the cos for us to solve for the length AM. So cos 20 degree, this is equal to the length of AM divided by 5.2. So AM is equal to cos 20 degree times 5.2, which is equal to 4.886. So now we can calculate the length AV using the sine rule. So it will be AV over sine 50. This is equal to 4.886 over sine 105. So AV is equal to 4.886 over sine 105 degree times sine 50 degree. So the answer for the AV will equal to 3.875. Question C. Calculate the surface area of VAB of the glass block. So for the triangle VAB, we already know the length of the three sides. Therefore, we can find the area using the Heron's formula. So first, we need to find the semi-perimeter. It will be 3.875 plus 3 plus 5.2. Then we're going to divide this by 2, which is equal to 6.0375. So surface area of VAB will be the square root of 6.0375 times 6.0375 minus 3.875 times 6.0375 minus 3 times 6.0375 minus 5.2. The answer is equal to 5.763. Questions number 9. Rashid drove a boat westward. He noticed a lighthouse at a distance of 25 km away at the bearing of 235 degree. A. Sketch a diagram to illustrate the above situations. So let's say this is the point that Rashid starts to drive the boat. The bearing 235 is start from the north clockwise. So it's probably will be here. So this will be the position of the lighthouse and the distance is 25 kilometers here. So this probably will be the positions of Rashid because we only know Rashid dropped the boat westwards. What we didn't know the distance. So this will be the diagram for the questions A. Questions B. What is the distance traveled by the boat if its distance from the lighthouse is 16 kilometers? So there are two possible positions of Rashid here because in this case it involves the ambiguous case. In question C, it mentions Rashid continued to drive the boat until his distance from the lighthouse is 16 kilometers again. So I assume this question is asking you to find the shorter distance traveled by the boat of Rashid. So based on the diagram, first we can find what is the angle here. So start from the north until the west here, the total bearing will be 270 degrees. So 270 minus 235, the answer is 35. So let's say the distance traveled by the boat, we label this as D. So the length of D here is opposite to the angle at the lighthouse. And this 16 kilometers is opposite to the angle 35 degrees. So first we need to find the angle at the lighthouse so that we can solve this using the sines rule. So this 25 kilometers is opposite to the angle here. And this angle will be an obtuse angle. And using the 16 kilometers, which is opposite to the 35, using sines rule, we can find the angle formed at the Rashid there. So let's say we name the angle here as angle R. Then this will be 25 over sines angle R. This is equal to 16 over sines 35 degrees. So sines angle R will be 25 times sines 35 degrees divided by 16. So angle R will be the inverse sines here, which is equal to 63.66 degrees. So the angle R is an obtuse angle. Then to find it, it will be 180 degrees minus 63.66. It is equal to 116.34. So now we can find what is the angle at the lighthouse here. So using 180 degrees minus 116.34 minus 35 degrees, the answer is 28.66. So now we can find the distance. So D over sines 28.66, this is equal to 16 over sines 35. So distance here is equal to 16 over sines 35 times sines 28.66, which is equal to 13.38 kilometers. Question C. Rashid continued to drive the boat until his distance from the lighthouse is 16 kilometers again. Number 1. Calculate the distance between the first position and the second positions of the boat. So this will be the second positions of the boat. The triangle formed here is an isosceles triangle. Therefore, these two angles will be equal to each other. And to find this angle using 180 minus 116.34, the answer will be 63.66. Then what we can do is that we can find what will be the angle here. So using 180 minus 63.66 times 2, so the angle here will be 52.68. So let's say we label the distance between the first position and the second position of the boat as x. Then using the cosine rule, we can find the x. So here x square, this is equal to 16 square plus 16 square minus 2 times 16 times 16 cos angle 52.68. So x will be the square root of this answer, which is equal to 14.20. Number 2. What is the bearing of the lighthouse from the board when the board is at the second positions? So here the second positions of the board will be the reference point. So from the north clockwise of the second position of the board to the lighthouse, so this will be the bearing. So here we know this is equal to 90 degree. So the bearing will be 90 plus 63.66, which is equal to 153.66 degree. Questions number 10. The diagram on the right shows the positions of 4 petrol stations J, K, L, and M in the district. Given the distance JK equal to 40 km, KL equal to 80 km, LM equal to 65 km, and the angle JKL equal to 44 degree. A. Calculate number 1, the distance JL. So here will be the angle JKL. So refer to the triangle JKL. The length of JL is opposite this 44 degree. So using the cosine rule, we can find the length of JL. As we have 2 sides and 1 included angle. So JL square is equal to 40 square plus 80 square minus 2 times 40 times 80 cos 44. So the JL will be the square root of this answer, which is equal to 58.277. Number 2, calculate the angle JML, which will be here in the diagram. So using the triangle KML, the angle JML is opposite to this 80 km, whereas this angle 44 is opposite to the 65. Therefore, we can solve this using the sine rule. So this will be 80 over sine angle JML. This is equal to 65 over sine 44 degree. So sine angle JML will equal to 80 times sine 44 degree divided by 65. So the angle JML will be the inverse sine here, which is equal to 58.76. Number 3, calculate the area of KLM. So in the triangle KLM, we already know the length of LM and KL. So if we can find the included angle at the L here, then we can solve the area using the formula 1 over 2 AB sine C. So angle L is equal to 180 minus 58.76 minus 44, which is equal to 77.24. So area KLM will be 1 over 2 times 65 times 80 times sine 77.24, which is equal to 2535.79. Questions B. Without doing calculations, determine the petrol station which is the furthest from petrol stations K. Explain. So let's say you have a triangle ABC look like this. So in this triangle ABC, the length AC is the longest. And this length of AC is opposite to this angle B, which is the largest angle in this triangle ABC. This means in a triangle, the sides which is opposite the largest angle will be the longest. So now let us look at the triangle KLM. The largest angle is the 77.24, and km is opposite to this largest angle. Therefore, the length km is the longest. Therefore, petrol station M is the furthest from petrol station K. Question C. If a car travels along the road KL, calculate the shortest distance of the car from petrol station M. So in order to get the shorter distance, we need to draw a vertical straight line from the point M to the straight line KL, which is also perpendicular to the straight line KL. So this blue line here will be the shortest distance, and the angle here will be 90 degrees. So let's say we label the shortest distance here as X. So now let us refer to the right angle triangle on the right hand side here. Using the angle 77.24, the shortest distance here will be the opposite side, whereas this 65 km will be the hypotenuse. So using the trigonometric ratio of sines, which is equal to the opposite sides over the hypotenuse, then we can find for the x. So here sine 77.24, this is equal to x over 65. Then x is equal to sine 77.24 times 65, which is equal to 63.395. Questions 11. Mary color the three triangles ABC, ACD, and CED such that ACE and BCD are straight lines. Given angle DCE equal to 50.05 degree and the angle CED is obtuse. A. Calculate number 1, the angle CED. So based on the diagram, the angle CED will be here. So here let's look at the triangle CED. So the angle CED that we want to find is opposite to the 7 cm, whereas this angle 50.05 is opposite to this 6.5. So using sines rule, we can solve for the angle CED. So 7 over sines angle CED, this is equal to 6.5 over sines 50.05. So sines angle CED will equal to 7 times sines 50.05 divided by 6.5. So the angle CED will be the inverse sines here, which is equal to 55.65 degree. But the angle CED is obtuse. To find the obtuse angle of CED, it will be 180 minus 55.65, which is equal to 124.35. Next, we want to calculate the length of AB. So for this case, we're going to refer to the triangle ABC. So here the angle ACB will be the same as 50.05. And the length AB is opposite to this angle. So with two sides and one included angle here, we can solve this using the cosine rule. So AB square, this is equal to 5 square plus 9 square minus 2 times 5 times 9 cos 50.05. So AB will be the square root of this answer, which is equal to 6.943. Number 3, calculate the area of triangle AED. So here I'm going to find the area of the triangle AED using area of triangle ACD plus area of triangle CDE. So in triangle ACD, I already have two sides. So I just need to find what would be the included angle ACD. then I can find the area using the formula 1 over 2 AB sine C. So angle ACD will be 180 degree minus 50.05, which is equal to 129.95. So the area ACD will be 1 over 2 times 9 times 7 times sine 129.95. As for triangle CDE, I also already have two sides, so I just need to find the included angle CDE. So angle CDE is 180 degree minus 124.35 minus 50.05, which is equal to 5.60. So area triangle CDE will be 1 over 2 times 7 times 6.5 times sine 5.60. So the area of the triangle ACD will be 24.148, and the area triangle CDE is 2.220. So the area triangle AED will be 26.368. Questions B. The straight line AB is extended to point B such that CB, the image, is equal to CB. On the same diagram, draw and color the triangle BCB image. So this is just like the ambiguous case. So here the moving points will be the point B. So here we need to move the point B upwards. So here will be the new positions of B, the B prime, which is the image. And later we're going to connect the points B primes to the C. And this will be the triangle BC B prime. Questions 12. In the diagram on the right, WYZ is a straight line. Given since angle XYW equal to 10 over 11, A. Find sine angle YXZ. So the angle YXZ will be here. So from the informations here, the angle XYW will be here. The angle XYZ will be the supplementary angle for the angle XYW. Therefore, the value for the sines XYZ will equal to the value of the sines XYW, which is equal to 10 over 11. So for example, the angle 150 degree here is the supplementary angle for the 30. Therefore, the value of the sines 30 degree will equal to the value of the sines 150 degree, which is equal to 0.5. So now let us look at the triangle XYZ. So the angle YXZ here is opposite to the 4 cm, whereas the angle XYZ is opposite to the 12. So using sines rule, we can find the value of the sines angle YXZ. So 4 over sines angle YXZ, this is equal to 12 over sines angle XYZ. So here we know that the value of the sines angle XYZ is equal to 10 over 11. So here we can replace the sines angle XYZ with 10 over 11. So when 12 divided by 10 over 11, the answer is 66 over 5. Then sines angle YXZ will be 4 times 5 divided by 66, which is equal to 20 over 66. So we can simplify this by dividing it by 2. So the answer is 10 over 33. B. Calculate the area of triangle XYZ, hence finds the length of XW. So from the questions, we know that sines angle XYW equal to 10 over 11. Then to find what is the angle XYW, it will be the inverse sines of the 10 over 11, which is equal to 65.38 degree. Then the angle XYZ here will be 180 degree minus 65.38, which is equal to 114.62. So in question A, we already know that the sine angle YXZ equal to 10 over 33. So the angle YXZ is equal to the inverse sine of 10 over 33, which is equal to 17.64. So now we can find the angle XZY. So it will be 180 minus 17.64 minus 114.62, which is equal to 47.74. So now in the triangle XYZ, we already have two sides and one included angle. So we can find the area using the formula 1 over 2 AB sine C. It will be 1 over 2 times 12 times 4 times sine 47.74, which is equal to 17.762. So now we're going to find the length of XW. So for a right angle triangle, we know that we can find the area using the formula 1 over 2 times base times height. So for the second triangle here, we can also find the area using the formula 1 over 2 times base times height. But how about for the triangle number 3 here? We can also find its triangle, the area using the formula 1 over 2 times the base, and this will be the height. So the triangle number 3 here is similar to the triangle XYZ that we have here, whereas the XW is the height. So for the area of the triangle XYZ, if we use 1 over 2 times base, which is the 4 centimeter, and time with the height, which is the length of the XW, this will also give us the answer of 17.762. So this 1 over 2 and this 4 we can simplify it. Therefore, XW is equal to 17.762 divided by 2, which is equal to 8.881. C. State two situations so that the ambiguous case exists in the triangle on the right. So the first situation is the length XY and XZ remain the same, and the angle at the Z here is remain unchanged as well. So here, if we move the point Y to the left hand side and we extend the straight line WYZ, the new position for the Y will be here. Then here we will have two different triangle XYZ. In situation number 2, the length of XZ and YZ remain unchanged, and the angle YXZ also remain unchanged. So here, the shorter side is the YZ, so we're going to move the point Y. So here we're going to move the point Y downwards, and we extend the straight line XY. Then here will be the new positions of the point Y. Then this will be another triangle of XYZ. And this will be the conditions for the situations 2 to happen.